This video finishes the Unit 1 notes from today. I had a prior video based on solving one variable equations and one variable inequalities. This one's all on compound inequalities. And compound linear inequalities, the word compound just means two inequalities combined into one, kind of like a compound sentence. You combine two sentences into one sentence with the words and, or, and I believe but is the other conjunction. So similar to English class, we're going to combine two inequalities with the word and with the word or. Let me talk about or first, because or inequalities are exactly what they sound like. It's like saying I want to say x is less than some negative number. Let's just say -3. It doesn't have to be negative. Let's say x is less than -3, or x is greater than or equal to 5. I don't know. So it's one or the other. It's not both, right? X less than -3. If you think of a number line here, oops, sorry, I'm using my fingertip as a mouse here. But if you think of a number line, and I do -1, -2, -3, -4, -5, 1, 2, 3. Here's -3. 1, 2, 3, 4, 5, 6. I don't know. 1, 2, 3, 4, 5. Like if I want to say x is less than -3, that means x is any of these values on this part of the number line. Or, meaning not both, there's no overlap, x has to be greater than or equal to 5. Well, here's 5, and every number greater than or equal to 5 is to the right here. So, or inequalities, or compound inequalities, you end up getting solutions that don't overlap. Versus an and inequality, and meaning both. So one way to think of these inequalities, I could say, well, let's say x is greater than or equal to 2, and it's also, I'm just making this up, let's just say it's also less than 6. I don't know, I just made it up. So here I kind of got a both, right? Greater than 2, well that's, or greater than or equal to 2, that's 2, 3, 4, 5, 6, 7, 8, so on. But it also has to be less than 6. Well, that's 5, 4, 3, 2, 1. So where do they overlap? So in terms of a number line, what that looks like, let me just start this one over here at 0. Let's say that's 0, 1, 2, 3, 4, 5, 6, I don't know, 7, 8. So here are the numbers we really care about. So 2 and 6. So if x is greater than or equal to 2, well, that would be everything to and to the right. But it also has to be less than 6. Well, here's 6, and less than is everything over here. So the solution ends up being this part in the middle, the both. This is what this inequality is showing. I want numbers that are greater than or equal to 2, but they also have to be less than 6. Now, our inequalities for and, we won't see this word and. They will look like a massive inequality put together, kind of like when you make a sentence with a semicolon. So what this inequality would look like is it would be a 2, and then less than or equal to x, less than 6. And let me kind of show you how both these inequalities are still in there. So originally inequality x greater than or equal to 2. Well, here it is, right? It's just flipped around. X is still greater than or equal to 2. And then x less than 6 is still here. It's just right here. X has to be less than 6. So this is how we tend to write compound and inequalities. Solving them, I'm going to do that down here in a second. To solve these compound inequalities for and inequalities, you want to isolate the variable in the center. So see this x here in the middle? We want just an x in the middle. And you'll see that over here in example 10 when we do this in a second. Or inequalities, what's so great about the or ones is you just solve them separately. There's no middle. I mean, there's just two separate inequalities. So let me do one of each type. And then again, I'll let you try 2 on your own and pause the video. So let me do, I don't know, let me do 9 and 12, and I'll let you try 10, or I'll do 9 and 10, and you can try 11 and 12. So 9, here we have a compound OR inequality. So to solve a compound OR inequality, I just solved the first one, I solved the left inequality, and then I solved the right one. So if I look at my left inequality, again, I'm kind of ignoring this side. I'm just looking at k over 10 greater than 0. I'm going to go ahead and multiply both sides by 10, just like we did in the previous video, and I get k is greater than 0, because 0 times 10 is 0. Or, now I go back and I solve the second inequality. The other inequality, k over 7 less than or equal to negative 1. Here I want to multiply by 7 on both sides. All right, so multiplying by 7 cancels that, dividing by 7. So I just have k less than or equal to negative 7. And that's it. Same rules apply before I go to the next one. If I multiply or divide by a negative, it's going to happen when you do this one down here in 11. When you eventually divide by negative 10, remember that inequality is going to flip around. So same inequality rules apply for these compound. It's just you're really solving, in the OR case, more than one. Didn't happen here in 9, though. All right, let's look at a compound AND inequality. So number 10 is a compound AND. It's just written kind of in like the English sense when there's a semicolon combining two sentences. Like I'm combining by putting the x in the middle. And that's where I want x to stay. I want this x to stay in the middle. I want to move everything else in the middle to both sides. So let me delete what I just drew there. So what I want to do is get x in the middle, meaning I need to get rid of the 7 plus. Well, to cancel that, I'm going to subtract 7. Now, I'm doing this to both inequalities, to both sides. So I'm going to subtract 7 from 11 and subtract 7 from 9. So what I end up getting is my final answer here is 2 less than just x in the middle. It's what I want. And then just less than 4 over here. And that's my answer. So go ahead, and if there's multiple steps, there's multiple steps. Like you'll see that here in number 12. You're going to have to add 3 to all the sides. Right? Add 3 to negative 13 and to 47. And then you're going to have to divide 5 to this side and this side as well. So pause the video, try 11 and 12. When you press play again, it'll show the answer. And I'll put some work with these two. So here are the answers to 11 and 12. I didn't show the work for 11. You just solve them separately, just like we did in the previous video. Be careful, though, in this second inequality, you subtract the 1, and then when you divide by negative 10, that inequality flips around. So just make sure you carefully check your inequality in number 11. And then number 12, here's my answer. If I had to, oops, I have a little typo here. Sorry, let me fix this. This shouldn't have been a negative 5 there. That means this should be a negative 2. That's my fault. But if that was a negative, if I divided by negative 5, both of these would flip. Obviously, I didn't, but if I did, if I had to divide everything by negative 5, both inequalities would have flipped there. So hopefully that goes well for compound inequalities. Let's do a couple applications. I'm just going to do one of them here and let you try the next one on your own. So same steps as the other applications. These are just going to be compound when I set them up. A Mexican tetra is a tropical fish that requires a water temperature between, this should give you the feeling of that and compound inequality. When my temperature is going to be between 68 and 77 degrees. So that's kind of like the sides of that compound inequality. Inclusive, that gives me an idea that I'm going to have inequality here, like including. So I'm going to have an equal sign in my inequality. An aquarium is heated, that's adding temperatures, 8 degrees, so the tetra can live in it. So heated means add. So whatever the temperature is currently, I'm going to heat it. I'm going to add 8 degrees to that. And they asked me, what could the original water temperature have been? I'm going to call it W before heating. So here's my inequality. There are other ways to figure it out without the inequalities. But there's my setup. So I'm going to go ahead and subtract 8. To isolate that W in the middle, the water temp in the middle. So I get 60 less than or equal to W less than or equal to, what is it, 69 over here when I subtract 8. So the water temperature before heating was between 68 and 69 inclusive. Go ahead, try this second example on your own. Press pause. All right, here's the answer to the second inequality or compound inequality application. A little strange one again. Most of you could probably figure this out without setting it up. If setting it up confuses you more, it's fine if you don't set it up. Just know the answer here. After she filled her tank and drove 45 miles, she has between 335 miles to go and 365 miles to go before she has to fill up her tank again. So this should cover everything that you'll see on the homework tonight. So that is your homework, and we will go over it tomorrow in class.